Large language models weaken the traditional relationship between reasoning and observable output. Students can now generate correct answers without necessarily engaging in the underlying reasoning process. coLearn-AI explores how collaborative learning environments can preserve reasoning through structured interaction and constrained AI scaffolding. Students work in structured collaborative groups with enforced turn-taking. Only one student can advance the shared activity at a time, requiring groups to coordinate reasoning before progressing. The activity begins with prediction and experimentation rather than immediate correctness. Students first predict what the program will do before running it. The goal is not immediate correctness, but making reasoning visible. Here, the AI notices the prediction is incomplete and redirects attention towards the loop structure, turning angle rather than supplying an answer. While only one student can submit to the shared activity at a time, students can independently experiment in the sandbox mode. This supports exploration without fragmenting collaborative learning trace. On the left, we see the instructor portal who can monitor progress, They can also view the actual activities as they are proceeding. The output often surprises students, creating opportunities for collaborative explanation and refinement. Small changes in turning angle and accumulate over time, producing emergent visual behavior. The first experiment is students then begin experimenting with individual parameters and observing how small code changes influence the emergent structure of the pattern. In this example, changing the turning angle from 89 degrees to 90 degrees dramatically alters the behavior of the drawing. Collaborative refinement. Students collaboratively refine their understanding through structured turns, experimentation, and visual feedback. Different parameter changes produce dramatically different emergent structures. Here, the AI again avoids supplying an answer directly, instead encouraging students to connect specific parameter changes to visible outcomes. Again, as we can see here, the students are experimenting with different values to see how that changes the output of the program, and then providing an answer. The AI feedback encourages them to think more deeply about what caused the observed changes. Epistemic trace. coLearn-AI preserves a persistent epistemic trace, an append-only history of predictions, revisions, experimentation, AI prompts, and collaborative interaction. The system captures not only what students answered, but also how understanding evolved over time. This creates visibility into the reasoning processes that are often lost in AI-mediated learning environments. Instructors can observe participation, activity progress, and reasoning traces and interaction histories across groups in real time. The system has been used extensively in 3 introductory programming courses and additionally in advanced computing courses, including data structures, applied algorithms, and software development. The goal of coLearn-AI is not simply to use AI in education, but to design environments where AI strengthens collaborative reasoning rather than replacing it.